In this video, we'll learn to use the formula to find the surface areas of 3D shapes. So I've got a cube, cuboid, pyramid, cylinder, prism and cone. So we'll take them in turn to see how we can find the surface areas of them. So surface area is the whole area of all faces all together. So it's a bit like thinking of wrapping paper they'd put around, or skin, or peel. So we'll work out the area of one of these, and apparently a cube has 6 faces, so we'll multiply it by 6 in this case because they're all the same. So if this is 4 centimeters and this is 4 centimeters, then we go 4 times 4 is 16. So this is 16. 16 times 6 . So 10 times 6 is 60. 6 times 6 is 36. So 60 and 36 is 96. So that is 96 centimeters squared. So we're looking at area, and that's why we've got squared. For a cuboid, let's suppose this is 4 and this is 2. So 4 times 2, which is 8. And then we'd have, so this would be 4 as well, and this is 4 as well. So then we go 4 times 4, which is 16. So this is 4 and 4 again, because they are the same. So another 16. And then this one is 2 and 4, because this is 4, this is 2. So that is 8. And this one here is 8. So what is left now is this one, which is again 2 and 4, just like these other faces. So that is 8 again. So we have 2 lots of 16, which makes 32, and we have 4 lots of 8, which is again 32. So that happens to be equal to 64 centimeters squared. So they happen to be the same, 16 and 16 32, and 4 lots of 8, 32, but it's not always the case. So it can have different values. So all we did was go around and add the areas of all the faces, and there were 6 of them in each case. Now we'll look at the pyramid, square-based pyramid. So if this is 5, then this is going to be 5 as well. And let's say this is 4. So this must be 4 because it is square at the bottom. So we'll look at the face at the bottom, which is 4 times 4. So that is 16. And then we'll need to look at each of these 4 triangles. So I said this is 5 and this is 5, but is that really important when you work out the area of the triangle? So what we need is this perpendicular line here, which forms a right angle with a base. So if I know that this is 4 and this is 4.5, so how do I work out the area? So I go 4 times 4.5 divided by 2, and that gives me one of the triangles. So 2 lots of 4.5 is 9, and another 2 lots is 18. 18 halved is 9, so one of these is 9, but I've got 4 of them. 4 times 9 is 36. So we've got 16 and the 36. 10 and 30 is 40, and the 12 is 52. 52 centimeters squared. And when it comes to the cylinder, what is important, as always with circles, is that we know the radius of or the diameter, either of them. So if this is 2 centimeters, then we can work out the area of this face, and then which is the same as the area of this face. So we've got 2 of them. Then we can work out the area of this other face. So to find the area of the face, I multiply pi r squared, so 3.142 times r is 2, so r squared is 4. So that gives me 12.568, but I have 2 faces that are the same, 2 circular faces, so I'm going to multiply this by 2 to give me 25.136. Now what I need to do is work out the area of this face. So what we need to know is how high this is. So let's suppose it's 4 centimeters, but we could also measure it, or you'd be told. And that is multiplied by this circumference, because this is how long this face is. That's the width and that's how long. So the length of it is equal to the circumference of this circle. So the circumference, so that's 4 times that circumference. The circumference we said we work out by multiplying pi with the diameter, or 2 lots of pi times r. So 2 lots of 3.142 times r, which is 2, that gives us 12.568. So that is the length, and the width is 4, so I'm going to need to multiply that by 4 times 4 to give me 50.272. So I've added these 2, I've got this. So in total we've got 50.272 plus 25.136. So that makes 75.408 centimeters squared. So what we did, we worked out the surface area of the circle, multiplied by 2 because there are 2 of them, and then worked out the area of this other face. Now we'll look at the surface area of this triangular prism. So again, we can see 3 faces that are rectangular and 2 faces that are triangular. So if this is 4 and this is 2, so we'd have 8, and then this would be 2 and 4, since this is an equilateral triangle. So 2 and 4, 2 and 4. So 8 and 8 and 8. So that is 24 for the rectangular faces. Now the triangular one, so if this is 2 and this is 1.7, for example, So we'd multiply 2 by 1.7 and then half it. So 2 lots of 1.7 gives us 3.4. Half of it gives us 1.7 again, because we're multiplying by 2 and we're halving, so that means we keep the number the same. So 1.7 on this side and 1.7 on the other. That gives us 3.4. So then we add them together to give us 27.4 centimeters squared. And finally, we look at the cone. Cone has a slightly different formula. So with a cone, you'd look at the base, so that is a circle. So we work it out by multiplying pi r squared. So if the radius of this is 2, then pi r squared is going to be 3.142 times 4, which is 12.568. Now we'll need to look at this, the area of this face. In order to work that out, we need this length, or the height, this slanted height here. So that goes a straight line down to the base. So you'd need a ruler to do this. So if that is 5 centimeters, then what we do with it is pi r multiplied by 5. So 5 pi r. So that slanted height is multiplied by pi r. So 5 times 3.142 times the radius, which is 2, gives us 31.42. So that all together, this, which is the surface area of this cone, works out as 31.42 add 12.568 to give us 43.988 centimeters squared again. So this was for the surface area of this face of the cone, but altogether this was 43.988 because we needed to include the surface area of the base. Now, if you're interested in why this works, keep watching. So we'll investigate to see why it actually works. So we'll rewrite the formula of the surface area of the cone again, which is pi r squared that was for the base, add, if we call this L, if we denote this slanted height by L as a length, maybe we can say then we work out as L pi r, the surface area of this other face. So why is this the case? If we look at this first part for the base, the first part, that gives us the base which we are familiar with. We know how to work out the area of a circle, and that's where it's coming from. So if I am to show it through a net, that's the part at the base. That's the base. That's the face at the bottom. So we'd put this together in order to make a cone, and that goes on top. And what we're interested in to find out is, why is this L pi r? So I want you to recall, where did we find pi r before, or something similar? And what it's close to is 2 pi r, which is the circumference of a circle. So pi r in itself is actually half of this, which means half of the circumference. So this circumference here at the bottom, we're talking about half of it. So to make the full circumference, we need 2 lots of this, or we could halve the full circumference and multiply it by L, which is this slanted height that we talked about. So what I'm going to do is I'm going to measure with a string this circumference of the circle, approximately, which is the same as this one. And what I'm going to do is I'm going to cut it in half. So instead of 2 pi r, which is this one, I'm going to get just pi r and multiply it by L. So I'll cut it in half. So now what I'm going to do is I will draw a straight line based on this, or the same, with the same length. So using a ruler, I will draw a line that is of the same length as the string. So placing it here, just a bit longer. So this is pi r, half of the circumference. What we're multiplying it by is L, which was this length, and in this case that could be anywhere, either here, there, or any of this. So this is exactly L. So I can put L here. As you can see, what I'm trying to do is to create a rectangle. So it would be perhaps better if I do it this way, ensuring that we have a right angle here, and this is where we've got to stop. So what I'm going to do now is cut off this bit. So it's got to be 90 degrees. And I will continue the line to try and meet this other side. So this rectangle that I've created is pi r times L. Now I will cut this bit and try and fit in there. So obviously it's a shape that I've got to play with, but you get the idea, because all these bits would make the whole shape when you put them together. So, to summarize, what did we discover? It is that pi r squared works out the surface area of the base, the circle at the base, this one here. L times pi times r works out because L being the slanted height multiplied by pi r, which is half of the circumference, gives us this face. So in other words, if we had a cylinder that has the same base, what we did with the cylinder, we multiplied the circumference by this height. What happens with the cone, you can multiply the circumference by the slanted height and divided by 2. So I can write here that this is for the cone, whereas for the cylinder we had 2 lots of pi r squared because we have 2 circular faces, and what we add into that is 2 pi r times h, and that is the difference between them two. I hope this investigation has helped you to look at surface area of the cone and help you remember.